Alright, in this third video, I'm going to explain specifically how you go about doing the final step in the image analysis. It's the most important step. It's the one that you'll be doing in the plasmid mapping. It's also the one that you'll be doing in the wet lab later this week. So if I skip down to look at the instructions here, it says analyzing images, measurement, determining DNA fragment length. So I'm not necessarily going to say it in exactly the right order or exactly the same words, but you'll still be the same gist. So what you have to do is you need to first determine you have to create your standard curve. In order to create your standard curve, you need to have a measurement for known lengths of DNA. If you look at well 0 here, this is your standard right here. So you'll see 2072, 1500, 1600, and 300. So make sure you calibrate, which we've done already in the previous video. And now in this video here, all I'm going to do is measure, plot, and then determine the lengths of these unknown cuts over here. So I'm going to click on my line tool. I'm going to go to the front of the well. I'm going to click and drag, holding on the shift button to make sure the line's straight. And then I'm going to measure that. And then I'm going to do the same thing for the next 1500 and measure that. And let me pull up the measurement window so you can actually see what's happening. I'm going to do that for the next 1000. Measure. And 600. Measure. And finally, 300. Measure. Okay, so if you look at my measurement window over here, the 1, 2, 3, 4, 5, so the last 5, those are my measurements, 5, 3, 2, 1, and 1. So now I'm going to come over here to my graph, and on my graph, I'm going to plot these points here. So my first graph is going to be for, remember it's a log paper, right? So log paper allows us to take in basically a curve and produce a straight line so we can get a curve. That makes no sense, but I'm not going to erase that. So I'm going to use this pen tool, and I'm going to go to my first value, which is a distance of 1.03, so let's say 1, and it is 2072 base pairs long. So I go from 1, I'm going to go all the way up here to 2072, which is going to be just above 2000 here, so about here. Let's make that nice and thick. And the next one is 1.4, and it's representing something that's traveled 1500 base pairs long. So I'm going to go to 1.4 here, which is about halfway. I'm going to 1500 base pairs. So 11, 12, 13, 14, 15 right here. And the next one is 2.068 for DNA that is 1000. So I'm going to go to 2. I'm going to follow it up to 1000. And the next one is 3.254 for DNA that is 600. So 3.2 and what's 600? So, and then finally the last one is 5.017. So let's say it's 5 for 300. So 5 at 300. Note I'm not being exact here because I'm on video and it's just in the interest of time. So when I look at this, it actually looks like a curve, doesn't it? Whenever you're doing these, you want to do the line of best fit. If the line of best fit is a straight line, you do a straight line. If the line of best fit is a curve, you do a curve. To make this more simple, I'm just going to make this a straight line. Let's see if a straight line will fit here. Alright, so let's see what a straight line does. So this is a straight line. If I was to do a curve might fit this better. I don't know if I could do it with the mouse. Well, yeah, see, that's not great. Right? So I'm going to go with the straight line. It's more accurate. Now, once I've done this, now I go back to my well here. I go back to my measurement tool. And now let's say I pick lane 3. So in the instructions it tells you to pick either lane 3, 4, or 5 and tell us the length of the drift lips that are in that well. So let's go with lane 4 because there's a few more things in here. So I'm going to go to lane 4. I'm going to measure to the first fragment. So click, hold down the shift button, measure, shift, go down to the second fragment, measure, shift, go down to the third fragment, measure, and shift, go down to the fourth fragment, measure. Right. So now I've measured 1, 2, 3, 4. So my last 4 pieces here are 6.32, 5.051, 4.32, and 1.186. So let's say I want to figure out the length of this fragment here, the one that's traveled the furthest. So what do I do? Okay, so I'm going to go to 6.32. So let's pick a different color here. Let's pick red, green. Let's make it about yay thick. So I'm going to go to 6.32. So 6.123, 6.32. And I'm going to find out where 6.32 intersects the line, which is right about here. So that tells me that that fragment length is approximately 120 base pairs. And if I were to look at the next one, it's 5.051. That means I want to figure out how far this how big this one is here. I'm going to go on my graph to 5.051, which is basically 5, and I'm going to see where it intersects the graph, and then I'm going to basically read that across and see it's approximately 270 base pairs long. All right, so I'm just going to make a quick little table here. Get rid of that Science Olympics thing there. Quick little table. And so in that lane, the one that traveled the furthest and was a size of 6.3, and it traveled 6.3 centimeters, and the size of the fragment length was, we decided, 120 base pairs. And the second furthest was 5.0-ish, 5.1, and based on the graph and how we read it off the graph, we determined that it was, here, read that across, we said it's about 270, 280, so 275 base pairs. Right, so number, drift lip, length, distance traveled, and length, base pairs. Alright, and then once you finish all that, you are now done that step.